The table of identification results here displays the results generated by the identification algorithm and indicates whether or not each of the selected elements has been identified as being present in each of the analysed spectra. In this example, 5 spectra were required at each analysis position, and Libsoft calculates a table of identification results for each spectrum. The spectrum number to map control can be used to select the spectrum for which the table of identification results is displayed. So it's currently set for spectrum 1, but if we change this, we can see how the table of identification results is updated. And as we'll see in further videos, the maps and the reference emission lines are also updated accordingly. But we'll reset this back to spectrum 1 for now. The row headers list the element symbols, and alongside each is a percentage value which indicates the percentage of the measurements in which that element was identified as being present. So we can see here that calcium was identified as being present in 100% of the measurements, whereas lithium was identified as being present in only 4% of the measurements. The column headers indicate the X and Y coordinates of the measurement which are extracted from the file names. So this is the measurement from position X equals 0, Y equals 0, X equals 1, Y equals 0, etc. The identification result for each element is displayed in the corresponding cell. So calcium at position 0, 0 is here. If the element is identified as being present, the cell background is coloured green and labelled yes. If the identification is inconclusive, the cell background is coloured orange and labelled with a question mark. And if the element is identified as being absent, then the cell is coloured red and labelled no. Left-clicking on the top left-hand corner of the table will toggle the display of the list of elements between being ordered by the percentage of measurements in which they were found, as shown here, and listing the elements alphabetically. So you can just toggle between the two. If required, the user can edit or manually overwrite an automated identification result by left-clicking in the corresponding cell in the table and entering the result. So, for example, we could change this to no, just by adding no, and it automatically updates the result. And we can even just type the first letter, so to change it back, if we select Y, return it to what it was. Left-clicking on one of the row headers will change the elements selected for display and update both the reference emission line panels and the maps to display data for the corresponding element. So if we now click on nickel, we'll see the display changing from reference emission lines for aluminium and maps for aluminium to those for nickel. So now I have nickel detection in spectrum 1, nickel reference emission line, and nickel reference emission line panels here. Note that this can also be achieved by opening the element identification configuration panel, so like this, and just selecting the element required for display in that. But it's often easier to do it from the table instead. Right-clicking on the top left-hand corner of the table will hide the spectrum display panel and expand the table of identification results in its place, so we can see more of the table, and we can see all of the table using the scroll bar and scrolling up and down. Right clicking again in the top left hand corner will return the display to its original form. Right clicking anywhere else on the table except the top left hand corner will display options allowing the data to be copied to the Windows clipboard or exported to Excel. So if we right click here, get a dialog allowing the data to be copied to the clipboard or exported to Excel.